Hello guys, welcome to my channel Sahaj Gyan, where we try to learn by building our intuition. In previous video, we have learned how to measure the position of an object with respect to a reference point in a frame of reference. For example, a person sitting in a moving train is at rest with respect to another person in a train in the train's frame of reference. However, the same person is moving with respect to an observer on the platform if we take the ground as a frame of reference. Therefore, for any measurement, you must have a reference point and a frame of reference. In this video, we will learn two important concepts, distance and displacement. When we talk about reference point, the most common example that comes to our mind is 0 in the number line. If you consider 0 as the reference point, the number to the right are positive numbers and the number to the left of 0 are negative numbers. In physics, with 0 as a reference point, we can think of right as east direction and we can think of left as west direction. If you see this picture, let's assume that my home is located at 0, which is the reference point. If my home is the reference point, then the building is 9 km towards east and the mountain is 5 km towards the west. We can also say that the location of the building is plus 9 km and the location of the mountain is minus 5 km. Please note how the sign captures the direction of the building and the mountain. Plus sign indicates eastward direction and minus sign indicates westward direction. Now that we have got a sense of reference point, direction and relation of sign with the direction, we will formally introduce the concept of distance and displacement. By definition, distance is the total path length covered by the object and displacement is the shortest path length between the start point and the end point. Please note here that distance is a scalar quantity. It has only magnitude. However, displacement is a vector quantity and is described by both magnitude and direction. For example, we said that the building is 9 km towards east direction or plus 9 km. Now let's try to understand this concept from a simple example of straight line motion. Here you see that the person has covered the total distance of 10 meters. First 6 meters towards the east, then he turns back and travels 4 meters towards the west. So in total, he has covered the total path length of 6 meters plus 4 meters, which is 10 meters. However, if you noticed, he is only at a distance of 2 meters from the starting point. Hence, we can say that the total distance traveled by the object or total path length is 10 meters. However, the displacement is 2 meters towards the east direction or plus 2 meters. Now, let's imagine that the person who has traveled 6 meters towards the east returns, travels 4 meters towards the west and continues his journey. Eventually, he will come to the starting point. And then let's say he continues to travel 4 meters towards the west. Now, can you see what is the distance traveled and the displacement? You can pause the video and take a guess. I'm sure you have got your answer right. In this case, if you see the total distance, which is 6 meters towards the east, 6 meters towards the west, plus the 4 meters towards the west. So total distance, which is the total path length, is 6 plus 4, which is 16 meters. However, if you see the displacement, which is 4 meters towards the west or minus 4 meters. Hope you got a little bit more clarity on the concept of distance and displacement. If you are familiar with the motion in 2 dimensions, this concept can easily be extended to motion in 2 dimensions. Here, you see that the total distance traveled by the object is 70 kilometers, represented by the green line. However, if you consider the displacement, it is only 10 kilometers in the southward direction. If you know how to denote the points in a plane, the point can be represented as 0 kilometer in the x direction and minus 10 kilometer in the y direction. So the displacement of the object is 0, minus 10. Now with this, we come to an end of this video. Let's quickly recap the important points of distance and displacement. Distance is total path covered. However, displacement is the shortest straight line path from start to end point. Distance is a scalar quantity. It has only magnitude. However, displacement is a vector quantity. It has both magnitude and direction. Distance is always positive. It can never be negative. And the minimum value of distance is 0 if the object has not moved. However, displacement, as we have seen, can be positive or negative. In straight line motion, negative displacement means the object is on the left side of the reference point, and the positive displacement means the object is on the right side of the reference point. Distance depends on the path. However, displacement does not depend on the path. It is the shortest distance between start point and end point. It only depends on start and the end point. With this, we come to an end of this video. I hope this video gave you a good intuition about the difference between distance and displacement. See you in the next video.